Hello everybody, welcome back to Virtual School Physics Fun. Wan Liao here. Okay, today we will continue with total internal reflection. What is total internal reflection? Now, the previous video, we have seen that when light travel from denser medium to less dense medium, so light will be refracted away from normal. As the incident angle increases, the refracted angle increases too. Okay, when the refracted angle is 90 degree, so the incident angle is called critical angle. So we see here incident angle increases, refracted angle increases too. So what if the incident angle increase more than critical angle, it increases further? So obviously this refracted angle will also increase, so it will bend down and comes into the water, the denser medium. So when it bends down to the same medium, it is no longer a refraction, but it is a reflection. So this is called total internal reflection. Okay, so total internal reflection will occur when light is traveling from denser medium to less dense medium. And of course, the incident angle must be more than the critical angle. Yeah, so it is a reflection. It's no longer a refraction. So therefore, incident angle equals to reflected angle. I equals to R. All right, let's look at the phenomenon of total internal reflection. The first one is what we call fish eye view. Okay, what is this fish eye view? Let's look at this picture here. As you can see, the fish can see the object that is on the surface of the water. For example, this grass and this one too. This is because the object is at 90 degree. Okay, the incident angle is critical angle. What about if the incident angle is more than critical angle? For example, this worm and this object A here. So this object, the light will be reflected into the eye of the observer. Okay, so therefore the fish can see this object, this, 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 and that. Okay, all this can be seen by the fish. Is it because the fish has got special eye? No, it is because of total internal reflection. Okay, all right, so these few pictures here shows us the fish eye view or the diver's view. Yeah, so you can see this person uh, looks like has got 4 hands. So these two are the real hand, these two are the reflection. This turtle, the reflection of the turtle. So you see water acts like a mirror. And this hand, which is the real hand, which is the object, which is the image. Okay, as it is explained in this picture. So the hand is of course inside the water. This is the real one. And this one above it is the image. Okay, mirage is another phenomena of total internal reflection. Okay, what is mirage? Let's view this video. Yeah, you can see on a hot day, from far you can see that the road is wet, puddle of water on the road. But as we go near, you see the puddle is actually not there. See, it disappeared. Okay, you see, there's no water. The road is not wet at all. So this is what we call mirage. Okay, how do we explain mirage? Now, on a hot day, the air above the road is hotter than the air higher up. So light from the sky, right, is propagating from cool air down, gradually down to hot air. And cool air is less dense. Sorry, cool air is more dense. Hot air is less dense. So light is traveling from denser medium to less dense medium. So it is refracted away from normal. Gradually keep on increasing the refracted angle and the incident angle until the incident angle is more than the critical angle, total internal reflection take place. Okay, so light is reflected into the eye of the observer, and when the observer see, so the image of the cloud as a puddle of water. Okay, so this is an explanation. You can find further from the internet. Yeah. All right, rainbow. Rainbow, beautiful rainbow is also because of total internal reflection. Water droplets, rainbow often occur after rain. Therefore, in the atmosphere, there is full of water droplets. So water droplets uh, will act as a medium for refraction of light to take place. Okay, so sunlight is refracted by this water droplet, and if the angle is more than critical angle, total internal reflection takes place, and then after that only it refract out into 7 colors. Therefore we see the beautiful rainbow. So for rainbow to occur, it takes 2 refractions and 1 total internal reflection. But sometimes we also see double rainbow. So you see, this is a primary rainbow and there is a secondary rainbow here. So how does double rainbow occur? So double rainbow will take 2 refraction and 2 total internal reflection. Okay, sunlight goes into the water droplet, refracted, total internal reflection once, total internal reflection the second time, because the angle of incidence still more than critical angle. And then after that, only refracted out. So 2 total internal reflection, 2 refractions. Well, diamond is another phenomena. Diamond is so beautiful because it sparkles. Why does it sparkle? Because light is reflected back into the eye of the observer. So we are observing diamond from above here. All the lights that enter diamond is reflected back. Okay, so how does it? How can it be reflected back and not refract out? So it is because of the cut, right? So the cut of diamond is very important. So if the cut is done correctly in such a way, so the incident angle is always more than critical angle. So total internal reflection takes place repeatedly, and then finally it's refracted out. Yeah, and of course, diamond has got very high refractive index, 2.42. Okay, with this high refractive index, its critical angle will be small. Okay, with small critical angle, the chances of incident angle more than critical angle will be high, so light will be reflected back, or total internal reflection can take place easily. All right, this is an experiment to show total internal reflection. Yeah, we shine, we fill water, bottle with water and punch a hole. When water spurt out and we shine lights into this jet of water, you see that the light does not refract out. It's not right here, but it is only lit up. It's only bright at the end. So this is the idea. This one gives an idea to scientists to create this thing called optical fiber. All right, so this is how optical fibers looks like. It is made of material that there are two layers of material. There is outer cladding and the inner core. The inner core have got higher refractive index than the outer cladding. So when light enters, so because it is traveling from denser to less dense medium, so total internal reflection takes place repeatedly until finally it's refracted out. Okay, so it is only bright at the end here. No lights is refracted out in the middle, right, in between. So you see here, light is reflected, total internal reflection takes place repeatedly until it comes out at the other end. Now, a cable, okay, cable instead of made of copper, now it is replaced with optical fiber, right? A bundle of cable with many optical fiber inside. So optical fiber is used by doctors, okay, by inserting this into the body of a patient. So this is called endoscope. So the internal part of the body can be lifted up and the doctor can see, can observe the internal organ clearly. In the field of telecommunication too, electricity is converted into light, right? And total internal reflection happens in the optical fiber, and then finally, when it is refracted out, it's converted back to electricity, right? So telecommunication is also using optical fiber. So therefore, we find that optical fiber is very useful. So what's the advantage of optical fiber as compared to copper wire? Number one, less signal loss, yeah, because copper wire have got resistance compared to optical fiber, there is no resistance. And number two, more information can be sent at the same time because optical fiber is very small, okay, and in one bundle of cable there are many optical fiber. Each optical fiber can send one information. Therefore, at the same time, at one time, many information can be sent together. Number three, it suffers less loss of interference. So signal will be more of high grade. Yeah, less loss of information. It will be clearer. Number four, signal cannot be tapped into easily. Okay, applications of total internal reflection. Cat's eye. I'm sure you have seen this picture. Okay, nighttime, we see the road as though there are light bulbs that is buried on the road. But actually, when you go near, there is no light bulb there. There is only these little things like this, right? Or even at the cars or even your bicycle, there may have these devices. Okay, so these are all prisms, right? That reflect lights. Yeah, light is when the car lamp is shine into this cat's eye, total internal reflection takes place and it is reflected back into the observer. That's why it looks like it is glowing. Okay, so you see, so beautiful. It's lighted up uh, to alert drivers that this is a sharp road, to guide drivers of the shape of the road, especially at sharp corners. Okay, periscope also uses total internal reflection. Yeah, of course, total internal periscope we can use mirror, right? Mirror to reflect light. But if we use prism, light is refracted into the prism and total internal reflection takes place. So this will produce sharper image, yeah, as compared to periscope that is made of mirror. Okay, right? So gives us sharper image. All right, so that's all about total internal reflection. We will end here and we will meet again some other time. Bye bye.